I'm going to do a classic Post-Mortem on game development Post-Mortem for Christmas Carol. I call From Pac-Man to Christmas Carol. It's essentially talking through the history of Christmas Carol, how it came to be, mostly about the development itself, how we started from Pac-Man, how it became its own thing eventually, and how we released it, and the differences and similarities between Pac-Man and Christmas Carol, so everybody understands how it works. And with that, let's go. So a brief history of Christmas Carol. So there's 3 stages of Christmas Carol development. The first started in 2008. We call them the Pac-Man days. That was back when I first started in the Intellivision scene. I bought my first Intellivision since I was a kid in 2008. And I then discovered that there was a thriving development community, homebrewer community, and I joined it, and I wanted to make my first game. I've always wanted to make a game since I was a child. It was like a dream of mine, and I've been a programmer for many years, so I figured, hey, might as well start making a game for the Intellivision, the console of my youth. So I started researching and reading into it and connecting with some people. There was a mailing list. There were a lot of people that were helpful and getting started. And I decided as for my first project to do Pac-Man. Pac-Man is a game that I've been fascinated about since I was a child. I used to play it back in the 80s so many times. I lost so many quarters on it, but I was never really that good at it. Yet I was fascinated by this game because this game, I always admired the fact that it's such a simple design. The graphics, the mechanics, the implementation, it's so simple, yet it plays like a complex machine. The way that the ghosts move is actually quite a simple rule-based algorithm, but it all adds up to make the behavior so complex that makes it feel like a really bigger. It's bigger than some of its parts, as they say. So I chose Pac-Man as my first project and started designing it for a couple of years, working on it on and off on my free time. And I got pretty close to finishing, as I thought, by the end of 2010. And at that time, I had already a basic framework for building the game, all the underlying machinery to run around the maze, for Pac-Man to be controlled through the maze, for the ghost to move. What I didn't have was the AI and the scoring system, but a lot of the subsystems were ready. There was no sound, but the presentation was there, and most of what I thought was the most complex parts were already made. So it was close to Christmas. I had a couple of weeks of vacation coming up, so I called my friend Joe Zapac, a wonderful guy that is so helpful in the community, and he's the stand-up guy that knows everything about Intellivision. And I was still starting, and I asked him for help, and I asked him if he wanted to start a project with me that it occurred to me for Christmas, to take what I had and theme it up for Christmas, making like little presents, Christmas trees, put Santa hats in the ghosts, and then share it with the community as a little silly Christmas present. It was mostly to be like a Christmas card. You play a simple game because I didn't have any AI ready. You play the simple game, you run around the maze, picking up presents as Pac-Man in a Christmassy theme game. And then at the end, when you finish all the dots, then it just tells you Merry Christmas and something like that. So Joe accepted, and he said that it would be a good idea. So then we started working together for the next 2 or 3 weeks. And then one thing led to another. And as many people know, it turned out to be a completely different game after that. We took the core of Pac-Man that I had, we added a whole bunch of stuff. We started changing the maze, and little by little, throughout those 3 weeks, it turned into a completely different thing. He created some wonderful sound effects, which gave it life. And then we shared it with the community by the end of the year, but actually by the beginning of the next year, in the first weeks of January. And it was well received. Everybody loved it. It was buggy as hell, but everybody loved it. And there was a lot of comments that people wanted to see it more polished, or maybe released in a cartridge with a box. So Joe and I decided that would be the best thing to do for the game. by then we already saw that it's got a great potential. So we thought it was a matter of just polishing it a little bit, maybe cleaning up a little bit here and there, adding a few simple features that we wanted to add, cleaning up all the bugs, fixing it up, and then releasing it in a couple of months. 18 months later, we finally finished the game. And we released it in its grand debut in 2012 in Las Vegas, Nevada, during the Classic Gaming Expo of 2012. By then, it was a completely different game altogether. It had the core of the original Christmas Carol game that we released back in January of 2011, but it had plenty more features. It had cutscenes. It had new levels. It had a boss level. It had new graphics. It had music. It had custom title screen, all sorts of different features, a practice mode, and everything. So it came out to be a really big production. And that's the history. So moving on to the technical design of Christmas Carol. So in order to talk about the technical design of Christmas Carol, we have to talk about its Pac-Man roots. They're still there. So Pac-Man, just like Christmas Carol, starts with a maze. The maze is the play field. Overlaying the field is a virtual tile map that subdivides the maze into little squares. I call it a virtual tile map because it's not really related to the background graphics themselves. It exists in memory in the computer, and it uses it to track all the sprites as they move around virtually through this path. The graphics themselves are just merely presentational. They're not used for collisions. They're not used for detecting walls. They're not used for anything like that. But they also guide visually the players, and so that he knows what's going on and where to move. In Pac-Man, the virtual tiles coincide with the graphics cards, but in Christmas Carol, because of the resolution is so smaller, it's actually, the virtual tile map is actually smaller than the background itself. So while Pac-Man has 8x8 cards, while the sprites are 16x16 pixels, in Christmas Carol, the sprites are 8x8, just like the background cards, but the virtual tile map squares themselves are 4x4. These virtual cards, these virtual tiles define a series of exits in the 4 cardinal directions. And these exits connect one tile to the other, forming a path. When you have a card with 2 exits on the same axis, you get a corridor straight. When the same tile has 2 exits in opposite corners, in opposite axis, you get a corner. When a tile has more than 2 exits, 2 or 3 or 4, sorry, you get a junction. All these, and the walls themselves are actually just a virtual tile with some of the exits closed. So all these cards together connect their exits, forming a path. In the case of Pac-Man, the path is a single corridor that runs the entire maze. In the case of Christmas Carol, as you can see, it's more open, but still there's a path that connects all the cards together with empty spots in between. Now, in Pac-Man, just like in Christmas Carol, the controls work for the player work in the same way. First of all, the position of the sprites is converted into the position in the virtual map, identifying which is the card that they're in. Then it detects which are the exits that are available in that card. So when the player presses a direction in the control, it will only go if that exit is open. This is how walls are implemented and corridors are implemented. So as you can see here, in the case of the left, you can see that the wall is on the left side. So the player, if he presses that side, he won't be allowed to go. So the sprite of the player will continue moving in the direction of travel that he pressed until either he lets go of the control or a wall is hit, which means an exit that is missing. That's how the player controls. How the enemies move around the maze is similar in both games as well. It's actually identical. First of all, once again, we use the virtual map to identify where the sprites are located in the virtual map. Then the enemy algorithm to detect its to find its path to its target, in this case is targeting Pac-Man. The first thing that it does is that it looks ahead in the next virtual tile in the direction of travel. From there, it detects which are the available exits that he can take. And at that point, it computes for every available exit what is the possible path using an algorithm called Manhattan distance, which is essentially just how many blocks you need to move in each axis across a grid to get to a destination. And as you can see here, the path to the right turns out to be fewer blocks than the one on the left. So that's the one that wins, and that's the one that the sprite is going to take. So at that point, his new direction is committed, but note that he's still in the previous tile. He will continue moving on that tile until he reaches the center of the new tile in the continued direction. And it will then switch and start turning until the turn is completed. Collisions are detected in a similar way. Once again, the position of the tiles in the virtual tile is in the virtual map is what counts. So in this case, as the sprites move, their position in the virtual map is tracked. And when two sprites reside in the same virtual tile, a collision is detected and a reaction is triggered. And the same thing happens with the items, whether it's power pellets or dots or presents or snowflakes, they have a position in the virtual map. And when a sprite's position coincides with it, a collision will be detected and an appropriate action is taken. And that's the underlying machinery of Pac-Man and Christmas Carol. It's exactly the same in both games. Now, the implementation in Christmas Carol is completely new. I have never seen the source code of Pac-Man. I've only understand how it works because I've been reading online certain different resources, the mechanics, but at a really high level, all the implementation is my own, and I try to figure out how to do it in my own way within the Intellivision resources. But they both work in exactly the same way. But it's also important to note that this is merely the foundation, the underlying machinery of the game itself. That's not what counts. What counts is actually what comes on top of it. Notice that over here, we haven't talked anything about the artificial intelligence that the sprites have in Pac-Man and all the sophisticated mechanisms that they use to move around and track Carol and track Pac-Man. And in Carol, as in Pac-Man, that's the most important part, what comes on top of this basic machinery. So let's look into what makes Carol unique. The first thing that you'll notice is that the maze is completely open. Well, basically mostly open. And that's important because it turns out that if you remove the walls from Pac-Man, you break it. You completely, utterly break it. Because Pac-Man's mechanics are fundamentally based on the fact that all the sprites are trying to get to a target and they're forced to go in a single corridor in a single direction without turning back and waiting until the next junction, which forces the player to figure out which is the exit that he's going to take and which corridor he wants to take before he commits himself in what could be a dead end with an enemy in front. And the same thing happens with the enemies. The way that the enemies move dynamically through the maze, trying to track Pac-Man in different ways, allow them to give the appearance that they're actually ambushing Pac-Man, when in fact what they're trying to do is trying to get to a particular point and are forced to go through different corridors to get there. When you remove the walls in Pac-Man, all that breaks down. And that's a bad thing if you're trying to mimic Pac-Man. But luckily, we were trying to create a new game. So it worked out for us. So an interesting thing happens when you remove the walls. The enemies in Christmas Carol still use the same mechanism that I just described for Pac-Man, which is using the virtual tile path to move around and try to detect and looking ahead and all that. But there are less walls, so there's more open spaces for them to turn around. So what happens is that they still have to obey the path, but they can find their path more directly towards the end, towards Carol. And it will make it really hard if it wasn't for the fact that Carol has actually a superpower. While the enemies move around in this path, they have to follow the rules of figuring out every single tile that they enter, what is the next direction that they're going to take on the next tile. And this slows their reactions somewhat. In the case of Christmas Carol, she has the advantage of the player being playing with his, using the controller in real time, just like in Pac-Man. And because there are no walls, she is able to nimbly maneuver herself through the corridor, through the virtual map as quickly as possible, while the enemies cannot. So that makes Carol almost impossible to catch. And it breaks down still the mechanics of the game because there's no much challenge, what we discovered. But the solution to this turned out to be pretty simple. We just bump up the speed of the sprites, of the enemies. And if you can see, we had to scale down the speed of Christmas Carol sprites by slightly little more than half than Pac-Man because of the resolution. But essentially, in Pac-Man, if you consider the first level, Pac-Man goes at 48 pixels per second, more or less, while the ghosts go all at 45 pixels per second. So that's slightly slower. And in the highest speed that Pac-Man goes in the highest level, he goes at 60 frames per second, 50 pixels per second, while the ghosts move at 57. So they're still slightly slower. In the case of Christmas Carol goes at 27 frames pixels per second in the first level, while the ghost goes almost twice as fast, and the snowman goes pretty fast as well, 33. And in the highest level, they go significantly faster, and this is very noticeable. And this would have made the game almost impossible to play if it wasn't for the fact that we also reduced the number of enemies. In the case of Pac-Man, you have 4 ghosts that you have to constantly watch out for and figure out where they're going. And in Christmas Carol, you have only 2 enemies. Now, they're really fast, but you only have to focus in 2. Actually, you only have to focus in 1, the ghost, because he's constantly moving and constantly going himself, moving from one side to the other and driving you crazy. He's the fastest one. The snowman is pretty tame. You have to, well, actually, he can kill you, but the snowman can just follow you, and you pretty much know that when he's in a corner, he can stay in that corner and you can move the other way. While the ghost is randomly picking directions and trying to move all over the place. Another thing that is different in Christmas Carol is the way that the mazes are configured. In Christmas Carol, there's not just one maze, there's actually 8 different mazes. But the differences between these mazes it's more than just merely cosmetic. It's not just the graphics, it's actually the fundamental mechanics of them changes. Just like I explained that whenever you remove the walls in a maze, it changes the mechanics. So it happens over here. We have a different set of mechanics in each type of maze. We have some mazes that are mostly open. We have some mazes that are mostly corridors, reversing the challenge. And we have a few that are just a hybrid of both techniques, where you have a set of large open rooms connected by long corridors. Another difference between Christmas Carol and Pac-Man is in the way that enemy states are handled. In Pac-Man, you have basically three enemy modes. You have scatter mode, chase mode, and frighten. Scatter mode is when they change directions and go to the corners and trying to follow a tile in the corner, and they spin around in place. Chase is when they switch directions and go back after chasing Pac-Man, and frighten is when Pac-Man eats a power pellet and then they go slower and then turn blue and Pac-Man can eat them. All these modes are globally shared by all the ghosts. What it means is that all 4 ghosts are in the same mode all the time, with really minor exceptions, like when you eat a ghost and he gets revived, he enters completely back into chase mode. But generally, all the modes are shared globally. So whenever Pac-Man eats a power pellet, all of them go into frighten mode. Whenever the game decides to switch into scatter mode, they all switch to scatter mode. When it switches back to chase mode, they all switch to chase mode. In contrast, in Christmas Carol, you have many more enemy modes. Moreover, the enemies themselves have somewhat of an agency between those modes. They have their unique set of modes that they can go to, and they switch independently from each other. There are no global game states that forces all the enemies to go into a single mode at a time. with the exception of probably the stunned one when the Carol eats a snowflake, similar to a power pellet. So the enemy states are, for example, in the case of the snowman, you have two enemy states. You have attack and stunned. Attack is when he tracks Carol. As soon as he goes into the screen, he's lethal on contact. He can kill Carol as soon as he touches her. Stunned is when Carol eats the snowflake and he becomes harmless. He essentially tracks the ghost, getting him out of the way of Carol, making her, giving her a chance to escape. The ghost has three modes. He roams around, targeting presence around the screen. He's not really lethal, but he damages Carol by removing the presents and putting them back in the screen. Carol is trying to pick up all the presents to finish the level, and he takes them back and puts them back on the screen. When Carol eats a snowflake, similar to a power pellet, and just like the snowman, he goes immobile and he goes harmless. Occasionally, while he's roaming, the ghost will time out and stop, and essentially just have a little animation where he looks around, looking like he forgot where he was going, and he picks a new target. So this is a cue that allows Carol to escape him while he's chasing her or while he's moving around. Then when you get to the boss level, there's a completely different mechanics there. There's two new enemies. One is the snowman has been melted down to a snowball and changes in the way that he works. He's got four main modes. He roams around trailing the bad toy. He damages Carol on contact by hurting her, and 3 hits causes Carol to die. When he hits, when he gets too close to the bad toy, he moves away, targeting a presence. So he's constantly moving close enough away from the bad toy, making him a little bit of a nuisance, getting in the way. Then when the bad toy zaps Carol with his laser, the snowball just runs to Carol as fast as possible and then just hits her. And then as soon as he does that, then he becomes inert by just splattering into a pile of snow for a few seconds. And these are the individual states that enemy can go into. Then there's finally the bad toy. The bad toy normally roams around tracking Carol, just like the ghost and just like the snowman does before him. But he goes in a really slow motion. But he always has his laser armed. He doesn't do any damage on contact. So if Carol touches the bad toy, nothing happens. But if the bad toy gets close within range to Carol of his laser, which is just a couple of virtual tiles, and he has line of sight to Carol, meaning that she must be in front in the same corridor, not across in a different corner, he will zap Carol with the laser immediately, and Carol cannot escape. What this will do is make her go slower, and then as a result of this, then the bad toy becomes depleted of his energy, and then he just stops and he's placed for a few seconds while his battery recharges. And then, of course, when Carol eats a snowflake, like all the other enemies, he goes inert and he pauses for a few seconds. Another difference between Pac-Man and Christmas Carol is that Christmas Carol is essentially story-driven. And I don't mean this in the same way that we have story games like adventure games in the 1980s. I mean this, there's a theme behind Christmas Carol. And Christmas Carol is wholly committed to its theme. It's Christmas. You're saving Christmas. You're exploring caverns in Christmas. The graphics, the mood, the music, the sound effects, even the prizes in the championship that we ran for a few years are all themed to Christmas. It's an entire world that is created with a small story that gives you an insight into the enemies and their motivations. And all this may not be specifically expressed in 8-bit graphics in the game, but it drove the development of the game itself. So while I was making this game and creating the mechanics and figuring out how to move the enemies and how to create the different tracking algorithms, what I'm thinking is on their personalities. What would they do? What motivates them? And sort of thing. Then there's the focus on adventure. Rather than just playing on a maze and running around, you are actually trying to save Christmas. Carol is going on an adventure, and you're helping her trying to save it. She has to avoid her enemies. She has to pick up all the presents. She has to survive 8 stages throughout the entire game, and at the end, save Christmas. Then there's also, of course, what everybody talks about, which are the cutscenes. These are little story vignettes that are shown during every 2 levels. As you progress through the game, you change stages. A new maze is unlocked, and a little animation sequence is played for you. And these animation sequences advance the story arc of the game. They're very subtle, and maybe not completely explicit in the story, because I mean it's a big graphics, and there's so much that you can do with the colors and the pixels. But essentially, the story, it's in my head as I'm trying to formulate this game. So it's trying to follow that story throughout. And it gives you a little bit of insight into the antics and the character interactions and how they play with each other. And you can see that the ghost is Goofy, stealing the arms of the snowman. And there's a bad toy that zaps Carol inadvertently. And then Carol gets panicked when she gets a present with a Jack-in-the-Box and so forth. Then there's the character motivations themselves, like I mentioned before. In my head, there's a little story. All these characters are not just sprites that run around trying to hunt Carol. The ghost is essentially just a misunderstood character. He likes presents a lot. He likes them so much that when he sees a present, he steals it. He doesn't know that he's stealing it. He just wants it. So it annoys you. It gets you in your way as you're playing the game, but that's his personality. The snowman, he's evil. He wants to catch everything. He wants to catch Carol. He wants to destroy Christmas. And the bad toy has been reprogrammed by the snowman. He's supposed to be a little toy robot, but he's been reprogrammed by the snowman to attack Carol, and then he goes haywire and he starts attacking the snowman himself. And all these little story things are hinted at in the little cutscenes that are in between the game. So I want to mention a few other innovations in the game that are not necessarily the game mechanics. These are based on the game framework itself. The first thing that I want to talk about is what I call the Joy Disc controller. This is the way that Christmas Carol handles the Intellivision disc controller. And it is distinct than many other games. Christmas Carol was created specifically for the Intellivision. Actually, this comes from its Pac-Man heritage. The Pac-Man implementation that I was making for Intellivision was strictly designed to be working with Intellivision. So it embraces the disc itself. Rather than treating the disc as a 4-directional controller, like a lot of games try to do to play a maze game, I embrace the entire 16 directions. There's actually an underlying heuristics algorithm that tries to detect, based on the information based on the last direction that the user plays, tries to detect where the user wants to go. So whenever an invalid direction is detected, it is assumed that perhaps the player was just rolling his thumb around in his way to a new direction. So we try to pick the most likely direction. And guess what? During practice, this turns out to be pretty effective. And it makes Christmas Carol a pleasure to play, much more so than many other maze games in the past in the Intellivision that try to just read the 4 directions or try to expand it into 8. There's also the P-Machinery engine, which is the game engine that I created for Pac-Man originally, and it survived through Christmas Carol. And eventually, I'm still working on it to try to release it at least someday, but still on the works. It's a general framework for game development. It's a state machine at its core. It divides the game into different phases, so you can switch from one phase to the other. And each one is like a little mini program. So playing the title screen and playing the game, or initializing or playing the game over screen, these are all different mini programs themselves, each one with their own set of variables in memory, like their own state machines and their own different hand controller decoders and things like that. And they're all bound together by the P machinery engine. It's object-oriented and event-driven, meaning that when Carol moves around and when the enemies move around, when something needs to happen, all they do is trigger an event, which eventually gets picked up and executed, and a reaction is induced. Then there's the animation engine that was created precisely for Pac-Man originally, but then eventually polished for Christmas Carol. It supports 9 simultaneous objects animated in graphics RAM. It actually cycles graphic RAMs. And when we're talking about 9 objects, we're talking about double resolution objects. So we're talking about 18 different cards animated in real time. It supports fractional frame rate and variable frame rate, so that the same animation can change its frame rate as it plays. It's state-driven, so that means that every sprite is independently controlled. As the sprite state or its mode changes, it can switch its own animation without having to depend on anybody else. So each sprite has its own individual animation at any point in time. Then there's something that I call the autopilot. The autopilot is a simple scripting language that I created originally for Pac-Man to try to recreate the cutscenes. And eventually this made it all the way to the cutscenes in Christmas Carol. This is what enables those beautiful Christmas Carol cutscenes. It's a really simple scripting language. It works in a similar way that many other scripting languages, a set of commands that allows you to control each individual sprite independently. It's kind of multi-threaded in the way that as each sprite engages its own scripting language, his own script, they all play simultaneously. So I can create a script for the Bat Toy and a script for the Ghost and a script for the Carol and have them walk around automatically into the screen and move around following a specific set of directions, move to here, stop here, do this reaction, change animation, and so forth. And this is what enables all those cutscenes. And this actually was a big breakthrough because it allowed me to just basically write these animations in a really simple way, like if it was a movie script. As you can see here in the screen, it's a little bit technical, but as you can see here in the screen, you can see that it says wait certain milliseconds, then enable the visibility, set the speed of the sprite, move it to this position, delay a little bit, then execute this animation sequence, then do this, then set the speed, then moving over here, and so forth. And that way I can create really complex animations, interactions between all these sprites by creating a simple script for each one. And I want to go into a little retrospective right now on the game itself, on the development. My lessons learned throughout the development of the game. So what worked? Well, there was a good foundation for the game. There were proven mechanics. Obviously, Pac-Man is a tried and true game. It's a beautiful game. It's almost a perfect game. So by using the core mechanics of Pac-Man, we know that we have the good bones for a game. Then there was a clear vision. From the very beginning, a lot of it grew organically, obviously, but I had a clear vision of what I wanted, in the sense that I wanted a game to be in a particular way. I wanted to theme it for Christmas. I wanted to add cutscenes. I wanted to tell a story. I wanted the enemies to have personalities, and I wanted to have all these features inside the game. And I really wanted to do this with the help of Joe Shabishik and a few other people. I managed to implement that vision. There was also a solid game engine, as you saw. The P Machinery engine was created for Pac-Man and it has been polished throughout the years. It's been almost 10 years now, but it has been polished severely. And it works. And it actually proves that a sort of like a core engine can be used for a game in that way without having to create something for every single game. Then there's also high-level frameworks similar to the scripting engine that I created, the autopilot. It allows you to think at a higher level. By making all these subsystems early, I get them out of the way and I don't have to worry about it. I can just focus on the animations themselves, on the scripts, on the mechanics of the game without having to worry about the technical implementation of those things. Another thing that worked really exceedingly well was the collaboration. Like I said, Joe Savicek's help was invaluable during this project at the very beginning and throughout. He's not only a great master at Intellivision, providing technical assistance, but he also designed all those sound effects that the game, everybody loves in this game, and they're unique to Christmas Carol. He designed them. He also tested the game thoroughly. He's the primary tester himself. He allowed all this collaboration with many other people that participated in the project throughout its beta test, provided design validation, telling me what works, what doesn't work, innovative solutions for different problems that I encountered. And of course, there was huge community support, a lot of testers, a lot of people playing the game, a lot of people supporting it, buying it, and joining in our competitions every year in the past. Another thing that worked really well was the original ideas. This came from everywhere. Not only the story that I had in my head, the cutscenes, the different player controls that I implemented, the new mechanics, but all these things, including a practice mode throughout the game, all these things added to the value of Christmas Carol. And just like Pac-Man, they makes the game more than the sum of all its parts. Another thing that helped a lot was having plenty of time. There was no deadline. This is a hobby project. No delivery pressure, no budget constraints. So I could work on it on my own free time, on and off as I could. And I continue adding stuff to it as much as I could. So what didn't work? Well, essentially, I don't think there was sufficient testing. Part of it was that we had a small pool of testers. It seemed like a lot when you get 10 people testing your game. And it is. But it's a really small set of people. And especially when these guys become so proficient at playing the game for months and months and months that that they just run through the game in the proper way, and sometimes a lot of bugs are missed. A bigger problem was my actual lack of discipline. I tend to just make changes and then hope for the best, and a lot of problems, a lot of bugs that crept up in the production versions at the end turn out to be part of this. A last minute change that I made, thinking that there was nothing to it. I just look at it, it looks fine, ship it, and then turns out to not be tested properly. There were plenty of bugs when we came out, and they're still there. A lot of them have been fixed over the years, and the new ROMs that I have released freely on the web are caught up with a lot of bug fixes, but I continue finding bugs up to this day. And another thing that insufficient testing provided was some people have complained in the past, and I admit it, that the game can be too hard sometimes and unforgiving. Yeah, that happens when you play the game so much for months and months and months in end, and you learn how to play it, and then you don't get fresh people testing it and telling you, oh, no, I can't start it. So those are things that I will hope to improve in the future. Another thing that didn't work was an emphasis on systems. Like I said, I worked a lot of time for 2 years in Pac-Man and for 1.5 years in Christmas Carol and building a framework and underlying subsystems. I have basically no game development experience, but I do design software in my regular career. So I focus on those things because that's what I'm comfortable with. And it led me to premature optimization of things that I didn't need to optimize. It also led me to throw away a lot of stuff that I built because I didn't know what I needed, and I just started building stuff that I thought I would need. And as it became apparent, the things that I needed, it became apparent that those things that I built were not sufficient or were inadequate. And I had to throw a lot of it away and rewrite it. P Machinery itself was rewritten 3 times during those 18 months that I developed Christmas Carol. This led to a lot of wasted effort. And another thing that didn't really quite work that well was that I actually had plenty of time. There was no deadline, no delivery pressures, no budget constraints. I just continued adding stuff to it and continue working on it and just adding more. Everything that turned in my head, I just continue wanting to add it. You have cutscenes and you have boss levels and you have practice mode. And at some point in time, we needed to ship. And so it's good to have a deadline. I discovered that. Otherwise, you never get to ship. So if I had to do this all over again, and if I could recommend something to other people that are starting, new developers that want to join the community, I would recommend starting small, preparing to throw away their first game. And by that, I don't mean just to throw it away in the trash. I mean, if you don't know what you're doing, you'll learn it as you go. So be prepared that at the end of your project is not the best thing that you wanted to do. This is similar to what happened with the first version of Christmas Carol. It turned out that it was just a prototype for what became Christmas Carol. And we can just easily throw it away. It's a single platform, it's a single level, and it has lots of bugs, and it doesn't do much of anything. But the end game, but it actually enabled the end game. I also recommend to convert or adapt, and not to port your first game. Find something that you like, a game that is tried and true, and try to adapt it to the Intellivision. Try to make it your own. Try to make it work and with the Intellivision limitations, and try to make it shine on the Intellivision. Don't try to just port it directly to it. Try to make the strength of the Intellivision be the strength of your game. But using an existing model of something that already works allows you to focus in those things that can make it unique without having to worry about how to come up with a brand new idea for a brand new game and new mechanics. And never be scared of trying new things. Like I said, everybody's used to using the disc controller, and a lot of people hate it. I had an idea that the disc controller can be a beautiful thing, just like a D-pad. You can roll your thumb through it if you code for it correctly. Embrace the community. There's a lot of people out there that will be willing to either offer help or test your games, or even just give you some motivation. So never be afraid of asking for help. Also, test, and never forget to test. Don't just think that it's a small change. Test it. Give it to somebody else. Make your wife play it. Make your children play it. Make somebody who's never played before, ask them to play the game so that you can discover new bugs. And never lose passion. Whatever you do, play with passion. Do it with passion. Have a vision and commit to it, and have fun. And that's the end. And I hope that has been helpful, and that it has been informative to all of you. Okay, I see a question here. What would you say was your main contribution to the game versus what Joe contributed, i.e., what was the division of the creative input? Well, I would say the game is my own. The idea was my own, the vision was my own. Joe helped a lot with some ideas, and a lot of technical assistance. There's some code that made it all the way through to Christmas Carol, especially the targeting system of the snowman. But I give Joe immense credit for it. I wouldn't have been able to make the game without him. But yes, the game was my own. It's my own code. It's my own design, my own implementation, my own ideas. And P Machinery itself, the underlying engine, is my own. Oh, and by the way, yes, the sound effects were created by Joe. So I gave him hints of what I thought would be cool, but he took those and he blew them out of the water. I mean, he came up with the tinkling sound at the end when Carol dies. That was fantastic. A small tester pool is indeed a problem with homebrew creation. Any ideas on how to compensate for that other than just paying people to test your game? Well, like I said, embrace the community. The best thing that you can do is to just broaden your scope. Just go out there and share your ROM. Ask people to test it. Do not be afraid of that. I mean, just ask people, and people will come in and play it. But you have to be nice, right? You can't just make some rules and tell them, oh, you got to do this, you got to do that. Just, be open. And be also open to criticism. If people don't like your game, they don't like your game. Take it. And, Yeah, that's another thing that I would also recommend. Like I mentioned, you should ask your wife or your kids or somebody who hasn't played the game too much. When you got beta testers, like what happened with Christmas Carol, we were beta testing. I thought I was done. I mean, we were only going to polish the game for a couple of months and release it by summer. And it took us 18 months. And it was because like I said, I had too much time. So I just continued adding stuff to it. We were on beta testing mode for almost an entire year. So imagine all those people that tested that game were super good at the game by the end. So I make a bug. If there's a bug in the game, they may not detect it. Some people were really good at that. They were actually trying to look for bugs, but eventually, you know, people lose interest, or they lose the motivation. When can we expect Carol 2? Well, if you should know, there's quite a few things in the pike. I hope to maybe next year have something, but don't hold your breath. I'm a really slow programmer. So just a little bit about the heuristics of the disk, so that people are mentioning here. The way that the disk detection algorithm works is that you have the disk, and when you press that direction, it keeps track of the last direction that you chose. And it expects, the way that I'm treating the disk is that I'm expecting people to roll around their thumb on the disk. So whenever we detect, we actually detect the cardinal points, north, south, east, and west, and then expand those zones a little bit with a little bit of the edges around it. But the perfect diagonals become, which is the problems, the perfect diagonals are ambiguous. You don't know what the player intended to do in the perfect diagonal. So a lot of games, what they do is they just ignore it, and it becomes a dead zone. So essentially, you move your thumb around. If you're moving your thumb, if you get to a diagonal, you stop, or the game doesn't react properly because it doesn't detect that diagonal. So in Christmas Carol, I do detect the diagonal. And I assume, and the whole thing is that the assumption is that because we're assuming that the user is rolling their thumb around, so let's say that you're going upwards, you're going north, so you're pressing north. And all of a sudden we detect the perfect diagonal going northeast. Instead of just assuming that's a bad input, what we say is, well, this is moving to the right, the user is going upwards, so perhaps what the user is doing is trying to roll their thumb towards east and didn't make it in time. So well, let's just assume that he's going east. So then he starts going east. And then the beauty of this is that because the maze is constrained in the exits that are available on each tile, then only the available tiles will allow you to move. So essentially, if it was the bad input, it will be discarded anyways, because you won't be allowed to move that way. And it comes out to be so effective that it's like magic. I'm really proud of it. Will a Carol 2 have similar mechanics, a maze game, or will it be a completely different direction? Well, I have a Carol 1.5 in the works that's going to have the same mechanics. But a Carol 2, the design that I have in mind is actually a completely different game. But I wouldn't hold my breath to that. It's been several years. I haven't even started it. So I would just expect more Carol 1.5 with same mechanics. What kind of bugs did you fix after production? Oh, wow, the infamous bug that was in CGE that I had to make a recall of all the games that we sold in the Classic Gaming Expo. It was a bug that caused the game to crash at the point that you finish the 7th level and you're going to the boss level. So you essentially will never get to the boss level. It just crashes the game unconditionally. And you can never finish the game and save Christmas. That was such a pity. So we had to make a recall. Joe was a fantastic guy in this. He just took it upon himself, accepted the recall submissions, and then he sent new cartridges to everybody. And essentially that was patched. But along with it came out another bug that we discovered soon after. It was a bug that actually caused the game to crash similarly, but this time in PAL. It was a timing issue between the differences between the European console and American console. From Gino, how long until P Machinery may be available for beta testing? Well, I was hoping to get it out this year, as a matter of fact. But let's say sometime maybe early next year or by the end of this year, hopefully. It's a game development framework, but it's still in assembly language. It's just run with a lot of macros, so it makes it higher level, but you still need to deal with programming. And the version that we have right now that I'm working on for the last actually since the release of Christmas Carol, that was 8 years ago. For the last 8 years, it's a lot more sophisticated than it's in Christmas Carol. And once again, with a lot of help from Arnold Chevalier and Joe Savicek, and a few others from the Intellivision programming community. Somebody mentioned about the newest ROM here in the chat, but the newest ROM, just bear in mind that the newest ROM is actually from 5, 6 years ago. So it's not really that new. Once Carol 1.2, 1.5 comes out, hopefully next year, the new version, it will include a patch version of the ROM with more bug fixes. There's bugs, there's so many bugs in there. Sorry about that. Do you think there could be a way for Intv basic coders to benefit from the great engine developed for Carol? Yes, that's one of my goals. So nothing in the works yet, but one of my goals is that when it reaches a maturity level that can be used, integrate it somewhat with the Intv basic SDK so that it can run. So that you can, because essentially it's just an overlay of a bunch of macros built on top of an assembly language engine. But those macros can very well be called as user macros from Intv basic. All you need to do is do the glue code to connect them. What are your plans for Carol 1.5 distribution? Well, honestly, probably CIB and a free ROM, because ROMs have to be free. And of course, a HAC, not a high school competition, a high score competition. Yeah, yeah, probably more Christmas Carol versus the World Championships. But like I said, don't hold your breath. I'm really, really slow. Question on the pathfinding logic. How often do the enemies recalculate their path? Do they recalculate the entire path or just the next step? Okay, so the way that it works is that every time that they move into a new virtual tile, right, in the map, as you remember when I mentioned, every time that they move to a new virtual tile, they look ahead to the next tile in the same direction that they're moving. And at that point, they check the exits, they compute the distance, they pick an exit for the next tile, and they continue moving until they reach that tile. And at that time, they turned into that new committed direction that they took. And then when they enter the next tile, they do exactly the same thing. So pretty much they're actually committed to a single direction every 2 virtual tiles, because one is for looking ahead, and once they get there, they calculate the next one. Any hidden eggs in Christmas Carol? Oh my God, yes, there is. There's a set of, there's a lot of Easter eggs that have been discovered throughout the time. There's a set of, there's even a kill screen, a fake kill screen that I made. There's a lot of special codes that you can enter from the title screen, and you get little messages. There's even an announcement in one of those codes that nobody has discovered, thank goodness, for my next game, saying that it was going to come out in 2015. And it actually says that, get ready for blah, blah, blah on 2015. And that was in 2012 when I thought 3 years, got plenty of time. And 8 years later, nothing on it. So Easter eggs, there's a, like I said, there's a kill screen. There's if you finish the perfect Christmas, which means you finish every single level, picking up all the items without dying once, and the entire eight stages, we call it the perfect Christmas. You get a little jingle at the end and a little message. Oh yeah, by the way, my wife wants me to remind everybody that the story of Christmas Carol actually exists. I wrote a book. It's a children's book. It's called Christmas Carol versus the Ghost of Christmas Presents. And it's actually the same story that's in the game, with the snowman steals the presents and he programs the robot and everything is there. It's a cute children's story. It's comes in hardcover. You can find it in the website carolversusghost.com. And it's yeah, I mean, it costs $24.99. I'm sorry for the plug, but I just had to say it. It's a really nice story. It's the entire Christmas Carol adventure. The snowman steals the presents. She has to rescue them. She goes on the mission, and all the little antics that you see in the little cutscenes, they're all represented in the story, but all built up. Well, the special edition of the game and the book, well, unfortunately, the game is out of stock right now. Hopefully, in the future, when we plan for a new release or a re-release at some point, hopefully next year, then we can plan for that. But in the meantime, the book, it's not really an Intellivision related thing, but it is a Christmas Carol related item. No stuffy toys coming out. Sorry, I draw the line there. All right, so I'm gonna let the next guy go now. So thank you for your time, and thank you for giving me the opportunity to talk about something that I'm really passionate about. Cheers.